The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
After we have identified those main effects, that we discussed previously, and also the interactions, we will be interested in graphing that specific factor, graphing those interactions. Notice that in this particular regard, we will be able to provide a summary. We will be able to have a specific plotted graph in order to say, for example, view test statistics. But remember that you will still need to conduct an actual test statistic to determine whether or not you were the main factor, that manipulation that you engaged in, whether or not your impacts, that variance that you observed, was in fact what led to that variance in the dependent variable, or perhaps because it was of individual differences. So keep in mind, even though you are graphing and you can see these interactions, you do want to also conduct your test statistic. So if we revert back to your slides, notice that we are going to have different factors that we are interested in graphing. Notice that one of the things that we can do is solely graph the main effects. So we're only interested in graphing the main effects. So if we revert back to your slide, notice that one of the things that you're interested in is we will be observing the changes. We will be observing the changes at the levels of one factor specifically. So notice, if I revert your attention to the slide, notice that we have the first factor. So we have the factor of setting, and we have the factor of duration, right? We have the factor of duration. Notice that we're only focusing on that main interaction, the interaction between factor A and factor B. Notice that if we are indeed interested in observing and understanding this table, notice that in this specific regard, we're only focusing on the main effect of duration only. So if I were to provide you with an explanation of this particular table, on this specific graph, notice that we're only focusing on the duration. Notice that in regards to the column means we're not necessarily using the specific means of the data, but rather that average factor, right? So we're only observing the means for the actual factor and not necessarily each level of each factor individually. So any questions about that representation of main effects only? Now, something really interesting about this specific graph is notice that if I were to use another method to illustrate these main effects, I'm going to revert your attention to this second figure here. Notice that in regards to anxiety, right? So here we are thinking about social anxiety levels. Notice that the higher the number, the higher the reported level of social anxiety. Notice that, for example, if we have a familiar setting or an unfamiliar setting and the person has to remain there for an hour, notice that the level of anxiety as reported here was an 8. Notice that if they had to be in a setting that was unfamiliar for 1 hour, they had the same amount of social anxiety. So notice that they reported in this case for an anxiety score of 8 and another anxiety score of 8. And this only represents an hour. It only represents an hour. Now let's graph the rest of our data. Notice that now we're going to look at the data as it represents 2 hours of duration in this particular setting. 2 hours is represented by the dotted line. Notice that in this specific regard, that group of individuals, that individual reported a factor of anxiety scored at 4 in a familiar setting when they were there for 4 hours. So notice that the score here represents the 4 hours of being in a familiar setting and being there for 2 hours. Notice that if we revert back to our setting, we have an unfamiliar setting, but now that individual has to remain there for 2 hours. Notice that the reported social anxiety level was at a 4. So notice that in this specific case, that's why the lines remain horizontal. That's why they remain horizontal. And again, this would be for 1 hour, and this would be for 4 hours. Notice that the overall mean for that specific data was 8, and for the second one for unfamiliar was 4. So now we are looking at our row means. So any questions about that? Now, if we observe the behavior, of those 2 lines that I was demonstrating. Notice that generally, what we're trying to look into is whenever we are trying to identify an interaction, what you would see is that these lines will not remain parallel. Quite the contrary. What's going to happen if you are expecting an interaction, say for example, you're looking into familiar and 1 hour, notice that if there was a specific interaction between a familiar setting and being there for an hour, these lines would not remain parallel. Quite the contrary, these lines would actually cross. I would make note that the interaction would be evident should those lines be or not be parallel. However, it is not necessary. It is not required that the lines actually cross or touch over, but it is a really easy way to find that representation should those lines cross. Now, something else that I need to remind you about when it comes to that specific interaction. Notice that when I'm looking at that interaction, we can see it visually, perhaps, because remember that they don't necessarily have to cross each other. But in order to determine and have a better understanding of that interaction, you should always conduct your test statistics. So just because you can't see this in the representation, it's always adequate that once you see this representation, you also conduct your test statistics. So you don't want to leave it simply to that specific analysis. You want to be able to conduct your test statistic. So let's revert back again to your presentation. Notice that now we're only observing in our second section, right? So we're going to look solely at the bottom, right? We're only going to look at this bottom graph. And notice here, we're still observing both factors, just like we did here. So for example, factor A with our setting and factor B with our duration. So we're doing the same thing. However, in this specific case, we see no interaction. So how are we going to conduct this specific aspect? Notice that here, we're going to observe the row means, and we're also going to observe the column means. And how exactly are we going to do that determination? Well, if I clear your slide a little bit, notice that we're doing the same concept once again. The setting is familiar or unfamiliar for the person who has scored levels of anxiety. And notice that we're also going to look at the duration that that person had to remain in, would be a familiar or unfamiliar setting for 1 hour or 2 hours. So if we revert to we look at the right side of your presentation, again, a solid line is going to represent 1 hour, and a dotted line is going to represent 2 hours. Notice that if we look at a familiar setting for 1 hour, notice that the score that we're going to obtain is an 8. If we revert to another score, which would be for 1 hour, but this time under an unfamiliar setting, notice that this graph now represents a 16. So notice that we do have a particular increase of anxiety. Now, if we were to revert now for the 2 hours, notice that the first score in a familiar setting, notice that the score was a 4 for a familiar setting. And for an unfamiliar setting, notice that the score was 12 as represented at the right of your screen. Notice that the more anxiety tends to be reflected in an unfamiliar setting. So here, we're not necessarily seeing an interaction, but what we are seeing is that main effect of the main factor. So factor A and factor B, so not necessarily in the sense of an interaction, but now we are observing the main factors. So any questions about that? Any questions? Now, if I revert your attention once again to the slides, notice that what we're trying to do, whether it be by a main effect or the interaction of the levels of that factor, the first thing that we're going to do is graph the cell means. Now, the next thing that you're going to do is you're going to see whether the lines in the graph are parallel. So that should be your first step. You're going to graph both the main effects and the interaction by looking at the cell mean. So for example, if we revert back to our slide, notice that in this specific case, we didn't necessarily use the cell means, but we were using the column mean. So we were using the main aspect in order to determine whether or not there was indeed a factor contribution. Now, after you do so, you're going to determine whether or not the lines remain parallel. If the lines are not parallel, it could indicate a possible interaction. Now, if you're only interested in looking at an interaction, we would expect to see changes. That in order for that dependent variable to be different, we would expect that one factor will depend on each in a specific level of the second factor. What does that mean? Let's look at another example, but in this case, instead of focusing on the main factors, we're going to look into an interaction. Notice that again, we have the example for factor A and factor B. Notice that in this specific regard, we still have the setting and the duration as our factors, but in this specific case, we want to see that they are different. Notice that if I were to explain this graph and try to analyze the aspects of anxiety, notice that it seems like the lower the anxieties, for example, we have a cell mean of 7. Notice that the less anxiety is represented in a familiar setting. So lower anxiety comes from a familiar setting, right? Less anxiety will come from a familiar setting. So if I clear your slides, let's look at what these representations of an interaction, right? Of an interaction would look like. So notice that again, solid line is an hour, dotted line is 2 hours, just like in our previous example. Let's plot this information that we have here. Notice that in the first case, we have a familiar setting for 1 hour. So the representation is then 7. Notice that in a familiar setting for 2 hours remains to be a number 2. Notice that if we move on to the unfamiliar setting, what we have for an hour, notice that just for the hour, it will be a score of 7. And for an unfamiliar setting for 2 hours, the rated anxiety was of a 12. So if I am looking at this graph compared to our previous graph, notice that in this specific case, there were no changes in that dependent variable. It remained the same. And in this case, our dependent variable, of course, was that of reported social anxiety levels. Notice that as I mentioned earlier, in order to understand that specific interaction solely based, or I should say changes solely based on that interaction, notice that we would observe a change, which was the case in this graph. Notice that the lines remained crossed and were not parallel. So any questions about that? Fantastic. Notice that this graph is going to be a little different. And why is that? Well, notice that we are going to see that interaction, right, in both aspects. So notice that we're going to see it both in regards to factor A, which is the setting, and factor B, but we're noting an interaction, not solid just with the factors as we did before. We're going to see that there are no main effects, neither factor A nor factor B necessarily were the ones that contributed to that change in the dependent variable. Notice that it was indeed the interaction. It was the interaction between setting and duration. So what does that look like? Well, notice that in regards to the previous example that we had, notice that the reported anxiety for this person in a familiar setting for an hour, in this specific case, was 12. Notice that if we keep along with the next sample, notice that for 2 hours, the reported anxiety was of 6. We revert back to an unfamiliar setting for an hour. Notice that this individual provided a score of 6. And in an unfamiliar setting for 2 hours, the person reported a score of 12, I should say. Notice that in this specific case, we are seeing an interaction in both cases, So say the person noted that in a familiar setting and unfamiliar setting, there was a change. Notice that these numbers remained different, suggesting an interaction. Notice that in regards to this specific graph, notice that there were no differences. No differences. Therefore, because there was no difference, we are going to assume that there was no impact on those main factors, that the main factors by themselves did not become contributors of that change in anxiety, but rather the combination and the interaction between levels. So any questions about that? Now let's think about a quasi-experimental approach, because previously we were talking about just regular experiments, but let's talk a little bit about that quasi-experimental approach. Notice that in this specific regard, if we revert back to your slide, notice that as we mentioned in our previous lecture, we can utilize a factorial design when we're looking at pre-existing characteristics in the quasi-experimental approach. Notice that when we are utilizing a quasi-experimental factor, an independent factor, let's look at participant variable. Generally, a participant variable is that demographic characteristic, right? So demographic characteristics. So when you're thinking about a participant variable, think about race, think about gender, think about socioeconomic status. So characteristics that are generally demographic, characteristics that tend to be demographic. The limitation that we may have, because we are indeed using that demographic characteristic, is that you are unable to show cause because you cannot manipulate that demographic variable. So for example, cannot manipulate that this group of people, they're going to be assigned as Caucasian. This group of people is going to be categorized as Hispanic because that's a characteristic that they came with. So therefore, it's going to affect the aspect of whether or not can I actually determine cause and effect in this specific case. Because of that specific limitation, the best case scenario is that you will be able to say, well, perhaps there is a relationship, right? There is some sort of association with these observed variables, but that will be the best case scenario. Best you can do is provide an association because you'll be unable to establish causal effects. Now, as we know, it may be difficult to include multiple factors. As we observed in our previous lecture, there could be instances, for example, orders of timing, aspects of the threats for internal validity, for example, when we're doing between subjects compared with within subjects. But there are many reasons, even though it is more complicated, there are many reasons that you may be inclined to include multiple factors, more factors in an experiment. One of the things that we're going to discuss here today is the reasons. So first reason would be because we are interested in building upon previous research. The second reason is because we want to start controlling for threats to validity. And the third reason is because we want to enhance the aspects of how much information can I get in order to provide my interpretation of my data. So let's look at each of these independently. Let's look at each of these individually. Notice that, as I mentioned, one of the first reasons that you would like to include multiple variables is because you want to build upon previous research. Notice that perhaps one of the first things that you will be interested in is trying to replicate. That will be one of the reasons that you're trying to include multiple variables, because you are trying to replicate a previous study. And why is that? Well, remember that one of your goals as a researcher is to contribute and build upon science, to contribute to the field. And in order to do that, you may be inclined to include more factors, because in including more factors, you may find a novel or perhaps an entirely new finding altogether. So imagine if you found this research that was already conducted with, or let's use anxiety and keep it with your previous example. So notice that you read an article about factors related to the setting, which was a familiar setting which they are with the friends. And notice that the aspect that they looked into was the duration, right? The duration in which they were in that setting. But imagine that you, as a researcher, that you're trying to include yet another variable. Say, for example, you are including the factor of setting, familiar or unfamiliar, the factor of how much time they're in that setting, but perhaps you're including a new factor. So for instance, during the daytime or during the nighttime, and trying to see whether or not adding this variable can give you new information, right? New information about information. So notice that because you included that new variable, the time of day, whether or not they were in a familiar setting for 2 hours during the day, familiar setting for 2 hours during the night, unfamiliar setting for 1 hour during the day, familiar setting for 1 hour during the night. And now, when you conduct your factorial design your factorial experiment, you'll see perhaps that there is a new piece of information that we simply did not know. But because of you trying to build upon previous research, we were able to find out new data. We were able to find new data. Now, notice that we're going to look at one of the examples that your book has presented. Let's suppose that you are a researcher and you're interested in testing a specific hypothesis. And in this particular case, I should say, you're trying to see whether or not the persons who give a firm handshake will receive positive evaluations whenever they are conducting an interview. Notice that in your hypothesis, what you're going to say is that individuals who did indeed provide a firm handshake will receive more positive evaluations. Notice that because of that, you can start determining whether or not this individual did in fact receive those positive evaluations. And you're also going to include another factor. Remember, because we want to include another factor. Notice that here, the factor that you started including was, not only are we going to look at whether or not they provided a firm handshake and got positive reviews, but also because they did it at the beginning and the end of the interview. So notice that was your other factor that you included. And firm handshake, factor A. We also had the positive evaluation as your dependent variable. And our factor B, but here we're going to include another variable. Notice that that is going to allow you to see and expand, not only replicate the previous study, but it's also going to allow you to expand the research that we had in this study. Any questions about that? Now, if I capture your attention to our illustration, notice that previously we were seeing the two factors, right? The two factor when it came to a factorial design, but notice that now I am including that third factor, right? I'm including the third factor. Notice that there are multiple ways that we can understand. So for example, in our previous instance, where we had a firm handshake, positive review, or positive evaluation, and whether or not we were providing it at the beginning or at the end of the interview. So notice that whenever we have a three-way factorial design, we're going to observe the three factors again. So factor A, handshake, factor B, evaluation. And factor C, which in this case would have been, you do it at the beginning and the end. Notice that we can observe two-way interactions. For example, the level of A is going to impact B. A level of B is going to affect the factor of C. And then the factor of A is going to affect the factor of C. Notice that here we are referring to an interaction. We're not referring to the main effect. We are not referring to the actual factor. So A, B, and C per se. What we're trying to say in that second row is that there's going to be an interaction between the level of A and a level of B, a level of B and a level of C, and a level of A between a level of C. Notice that here, if you notice, it's a two-way interaction because we had 1 and 2, 1 and 2, 1 and 2. But we can also have three-way interactions. Notice that when I am talking about a three-way interaction, what I am referring is that a level of A impacts or influences a level of C, that later B is going to impact C. And I'll say that again. Notice in a three-way interaction, it wasn't just that A dependent on B, A dependent on B, B dependent on C, right? So notice that there's a three-way interaction. Notice that in this specific case, we will not be able to conduct a four-way interaction. But if we were looking at a four-way factorial design, then yes, we would add yet again another factor in which A would affect B because B affects C, C therefore affects B. Any questions about that? Good so far. Now let's revert back to your presentation and notice that the second factor that we had talked about was I may want to include more variables because it allows me to minimize the threats that I may have concerning validity. Something that I like to think about is whenever we have a factor or a situation, and people like to think about, well, this person was a serial killer, right? So the act of violence because they were abused as a child, right? So factor A and factor B, right? So being abused as a child led to killing, therefore this person is a serial killer. But why do we want to include more variables? Well, because it allows you to eliminate potential threats of validity. Was it truly because the individual had that trauma? And now we can start including, well, trauma and education, right? So now we have A, B, and C. Trauma, education, and socioeconomic status, right? So now because we are adding more variables, we can see and go back and see if indeed that factor of interest was indeed the one contributing, right? So was it just simply because he was a person who was abused as a child? So we revert back to your presentation. Notice that you can test for the factor. You can test for the factor that you are interested in. So for example, in this case that I gave you, let's say trauma, right? How that led that person to perhaps become a serial killer. But say, for example, we started including all those aspects, all those other variables, for example, education, socioeconomic status. Notice that because of doing that, we can start noticing that we can add factors specifically that could be inherent to the individual. So what does that mean? Notice that we were evaluating for trauma, but say now you want to include gender. You want to include health, as your book illustrates. So notice that now because you have other factors that came from the person, so for example, gender and health, notice that now you can explore that dependent variable of being a serial killer. And you're going to start eliminating and minimizing threats, for example, for validity, that you are in fact measuring the propensity of a person to become a serial killer. This is actually done fairly extensively when we're looking at studies of sexual assault, right? So when we're trying to determine whether or not a person could be more likely to become a sexual predator, those are assessments that I have conducted in the past, particularly in a prison setting. So basically, what are the factors that could contribute for the person to become a predator? So if I give you a real life example of what this would look like, think about what puts a person at risk. Let's look at it the other way, not to become a predator, but think about what would make this person to become more prone of a sexual assault in prison. So for example, if it's your first offense, if it's the first time you've been to prison, that can make you more likely. If you are of a certain height and a certain weight, so for females, I think if you're less than 110, and for males, I think if you're less than 150, don't quote me on that. So that would be another factor. So we had how many times you've been in prison, your height and weight, and the type of crime, right? So is your crime nonviolent, right? You're not there for a violent crime, you're there for nonviolent crime. So for example, fraud, drug trafficking, right? So nonviolent crimes. So notice we have factor A, which was how many times you've been to prison. Factor B, height and weight. Factor C, when it comes to the type of your offense. So this is a real life example of how we would use factorial design in real life. Because this is going to allow me to minimize threats of saying, well, this person has the more likelihood of being sexually assaulted in prison. But notice that in that specific regard, because we have more factors, I'm able to eliminate, right? I couldn't control how many times this person's have been in prison. So that is a characteristic that that person came in with. So that can assist us in identifying characteristics that are inherent to the individual. So any questions about that? Now, very related to the topic that we just covered, notice that we would include more variables because we want to enhance. How are we to interpret that information? Notice that because you are adding more factors, you're able to analyze, well, let's see if the effects of these two or more factors occur simultaneously. So perhaps a factor by itself does not contribute, right? Does not contribute to that change in the dependent variable, right? So imagine that in the example that we had about anxiety, perhaps just studying unfamiliar setting and social anxiety levels, perhaps wouldn't give us a lot of information. Right? But if you start adding another variables, for example, we added duration. How long are you in this unfamiliar or familiar setting? Notice that now it's a little bit more informative. Now I can make better conclusions, right? Now I can have a better interpretation of my data because if I put simultaneously the factor A, which was setting, the factor B, which was duration, because I indeed added that second factor, I'm able to provide a better interpretation of that social anxiety as reported by the participants. Notice that another characteristic that we will find is that it allows us to analyze whether or not there is an effect of interaction. This is the only design that will allow us to view interaction. It is the only design that will allow me to see, if we revert back to your slides, it will allow me to see if there was interaction between factor A level 1, factor A level 2, and the rest of the levels. So notice that it is the only way that I can look into that specific interaction. Notice that another benefit in enhancing our interpretation, because we have indeed included other variables, is that we can look at those changes. Notice that because you want to evaluate the changes in a dependent variable, you can do so by looking across the levels of just a single factor. And you can also do it in regards to multiple factors and see how they interact. With the dependent variable. So we revert back to your previous illustration. Notice that you don't only have to focus on just level 1, factor 1. You can start now looking into different and crossing different levels and see if there was indeed a difference in that interaction, because that's what you're looking for. You're looking to see whether or not we have evidence to support that we had the opportunity to manipulate the effects on the dependent variable or not. Any questions about that? Let's talk about higher order factorial designs. When we are looking into higher order factorial designs, what we specifically are referring to is that whenever we are using more than 2 factors, we are utilizing more than 2 factors. Notice that one consequence on having to add multiple factors is that not only are we increasing the multiple factors, but inherently, we are also increasing the number of possible effects that we could ever observe. So notice that not only are you increasing the number of factors, but you're also increasing inherently the possible effects that you could observe. Notice that by the same token, you will have a higher order interaction. Because now you're not simply observing factor A and factor B, now you are observing multiple. So for instance, 3 or more factors in that factorial design. Very similarly, the number of possible interactions is also going to increase. So now you have the opportunity to observe more of that crossing, more of those interactions. Now, when I mentioned that you're going to have higher order factorial designs, remember, we are adding more factors, and because we're adding more factors, not only is that going to increase, of course, the actual main effects, but it can also increase the interactions that we could possibly observe, but that comes at a price. That comes at a price because it is more difficult. It is more challenging to observe all of those interactions. It is more challenging. So if we revert back to one of your illustrations, notice that in this specific case, because we had 3 factors, we have 4 factors. You increase the factors, we have factor A, B, C, and D, but notice that now we have increased all of those possible interactions. Notice that we have 2A, 1, 2, 3, 4, 5, and 6, compared to the 3 that we had previously, compared to the 2 that we had in another design. So notice that it is going to be a little bit more complicated. It is going to be complicated to conduct said research. Notice that one of the best ways to address that difficulty is that you could perhaps graph the findings. But you're going to have to plot that data in 3 different axes. Right? You're going to have 3 axes, and of course, that is going to be more difficult. Generally, most researchers will often limit the number of factors to just 2 or 3, if it is possible, because observing higher order factorial designs is immensely complicated. Right? So if possible, you would like to avoid using 4 or more factors. All right, beautiful people, that is the end of our lecture.